So if there are any questions from the audience, please make your way to one of the microphones. Go ahead.
Hi. I have one question each for the two speakers, one here and one online. For Mark, it's more a kind of philosophical question. How can you envisage how two different oncogenes in cholangiocarcinoma give rise to two different immune microenvironment? Because I'm sorry for bringing always the example of lung cancer. In lung cancer, we make the complex story short because we say oncogene-driven lung cancer occurs in non-smokers, and non-smokers can have a different immune microenvironment compared to smokers. How can an EDH1 mutant cholangiocarcinoma have a tumor microenvironment different from an FGFR2 positive one?
I mean, I guess I'll answer philosophically that I think cancer is, at its core, it's a genetic disease, and it's defined by its genetics. And so, I think the microenvironment of FGFR2-driven cholangiocarcinoma may actually end up being quite similar to the microenvironment of FGFR3-driven bladder cancer more than, undifferentiated cholangiocarcinoma. So I think we're moving from an era where we defined cancer anatomically to an era where it's defined by its genetics, and I think the microenvironment is different across different cancers largely because of the underlying genetics. I mean, the most obvious example, of course, is mismatch repair deficiency, but I think that's just the tip of the iceberg.
Thank you very much. And for Qibiao, I dare ask you this because we exchange a lot about futibatinib in mouse. I ask you about the doses that you use in your in vivo models, infigratinib, pemigatinib, and afatinib were used at the respective doses that you can achieve in humans, meaning that the milligram kilo that you use in mice allows you to achieve the same concentration that you achieve in humans.
Yeah, that's a good question. So we actually use the clinical relevant dose for the mouse treatment, either the afatinib treatment or the PEMI treatment or the infi treatment. So I think they can all achieve the clinical relevant dose resemble to human dose. Yeah.
Yes, only because I'm a little bit, let's say, scared about combining afatinib that is by itself not a completely safe drug with an FGFR inhibitor. So I wondered if these good results in vivo could be achieved also with kind of suboptimal doses of the three drugs. But it's only a comment.
Yeah, sorry, so, and I realize it's your fellow that's working on the IDH model, but as it gets back to the mechanisms of the differences, have you looked at the secretome between the SB1 cells and the SB1 IDH mutant cells to see what's going on from a secreted protein standpoint?
Yeah, no, it's a great question. Is this working? Okay,
yes,
sorry. Yeah, so I think it's a tremendous question. We've confirmed that they secrete 2HG as you would anticipate, and we have ongoing work to understand what else is secreted and some proteomic studies. And I think a particular interest of ours is, how do these secreted oncometabolites, how do they affect the stroma, which I think is something that is largely unexplored. So a lot more to come. Good question.
Greg?
Yeah, my question is for the third speaker. Have you looked at the cancer-associated fibroblasts in those various models? Because you implied that platelet-derived growth factor D was part of the secretome, but it seems to me it would also have an effect on all the platelet-derived growth factor receptors on the myofibroblasts in the environment.
I don't believe that Dr. Martin is on the live stream. He was a recorded talk.
Oh, okay. So I'll just ask Mark the same question, because you've looked at all the inflammatory cells, but it seems to me that calves are equally important in those subsets. And
No, I hope to have more to share. Yeah, part of the reason, the enthusiasm for doing Codex is that, instead of just getting bulk RNA, we'll be able to understand structurally what cells have what markers. So a lot more to come. But I don't know if you could see from those couple of images I showed, the stroma is pronounced an IDH1 mutated disease, as you might anticipate.
I have a quick question for Dr. Wu. Based on the mechanism of EGFR upregulation and location, if you could place it, is it receptor level or below, and would that have any bearing on what kind of EGFR inhibition is used?
Yeah, so in our study, we actually use most of the EGFR inhibitor as afatinib. It's EGFR HER2 inhibitor, but we have also tried the EGFR specific inhibitor gefitinib, as well as another EGFR inhibitor, EGFR HER2 inhibitor EKB. So we've also seen the similar efficacy of the combination of EGFR and FGFR treatment. Yeah.
Would this be distal to or downstream from a monoclonal antibody receptor inhibitor? Combinatorially, that would be probably more tolerable, is the reason why I asked.
Yes, but that's a good question. So if we use the EGFR like mono antibody, probably would decrease the toxicity, but we actually don't have the data to prove this. Yeah, so but we can try. Yeah.
Well, thank you so much, and congratulations again to all the fellowship award recipients.